Hey, welcome. So today, we're going to stop just reading about Python and actually start building with it. If you're ready to turn that theory into real skills you can actually use, then this is the roadmap you've been waiting for.
Does this sound a little too familiar? You've watched hours of tutorials, you know what a for loop is, you get the idea of a function, but the second you open a blank code editor, you just freeze. You have no idea where to even start. Yep, that's the infamous tutorial loop. And trust me, we're gonna break you out of it for good. And this right here, this is the core philosophy for everything we're talking about. Learning the rules of a game is one thing, but you only really become a player when you're on the field, making split-second decisions and reacting to what's happening. Coding is exactly the same. So how do we make that jump from the sidelines to the playing field? Simple. We build stuff. This approach, learning by doing, is the bridge that takes you from just knowing the roles to actually playing the game of programming. You see, building a project forces this crucial shift in your brain. You're not just memorizing syntax anymore. You have to break a big idea down into tiny, manageable steps. You finally understand why you need a loop in the specific spot, or why a function makes sense right there. And maybe most importantly, you learn how to debug, which is, no joke, the single most valuable skill any developer has. All right, let's see this in action with our very first project. We're going to start with a classic, the simple calculator. Now, I know it might seem a little basic, but it's the perfect way to learn the fundamental language of pretty much any program. You take some input, you process it, and you give back an output. With just this one tiny project, look at all the core concepts you're hitting. You're taking input from a user, which always starts as text, and you have to turn it into a number. That's called data casting. Then you use if and else statements to decide whether to add, subtract, multiply, or divide. I mean, this is the absolute bread and butter of programming logic. And this, right here, this is how a programmer thinks. You don't just start writing code randomly, you make a plan. See this? It's a clear, logical flow. Get the inputs, make a decision, do the calculation, and show the result. And that last step, handling errors, that's what turns a simple script into a really solid program. So here's the kicker. Your simple little calculator uses the exact same core logic as a massive, complex backend system. Seriously, when you fill out a form online, what happens? The server takes your input, processes it, and returns a result. You're not just building a toy, you're learning the fundamental pattern behind thousands of real-world apps. Okay, project number 2. We're leveling up now. We're moving from a simple one-and-done calculation to creating a truly interactive experience. We're going to build a guess the number game, and this is all about creating that dynamic back and forth between the user and your program. Now we're adding 2 really powerful new tools to our belt, the random module and the while loop. And that while loop is so important because it lets our game keep running until a specific thing happens. In this case, until the user guesses the right number. This is what creates that feeling of a continuous interactive game. This step-by-step logic introduces a super important idea called a game loop. See how steps 2, 3, and 4 just repeat over and over? That loop is the beating heart of the game. It takes a guess, it checks it, it gives feedback, and then it waits for the next one. This interactive feedback loop is a core concept in everything from video games to user interfaces. And that game loop logic, it's incredibly powerful. It is not just for games. Think about a chatbot or an AI simulation or any program that has to constantly check for updates and respond to them. They all run on a similar principle, a persistent loop that's always processing information and reacting in real time. Okay, so you've built the game. It works. That's awesome. But the journey doesn't have to end there, right? A great developer is always asking, okay, how can I make this even better? What other features can I add? And here are just a few ideas to get you started. What if you added a hard mode, where the number is between 1 and 1,000? Or what if you only gave the player 10 tries to guess? And hey, for a real challenge, could you figure out how to save the high score to a file so it's still there the next time you play? Each of these upgrades is like a mini project that teaches you a brand new skill. All right, for our final project, we're building something that is genuinely, practically useful, a tool you could actually use every single day. We're going to write a script that automatically organizes a messy folder, like your downloads folder, into clean, categorized subfolders. This is where Python really starts to feel like a superpower. This project is a huge leap because now you're making Python interact directly with your computer's file system. You're going to use Python's built-in OS module to read file names, check their extensions like JPG or PDF, and then actually move them from one folder to another. We're not just playing with data anymore, we're manipulating real files on your computer. The logic here is just, it's so beautifully simple and powerful. The script loops through every single file in a folder. For each one, it just asks, hey, what kind of file are you, based on its extension. If it's a .png, boom, it goes into the images folder. If it's a .docx, it gets moved to documents. It's like you've built your own personal digital librarian. And why is this so important? Because this is a direct professional skill. DevOps engineers, system administrators, they write scripts just like this all the time to manage servers, process log files, or automate backups. Building this tool isn't just a learning exercise, it's a genuine taste of what it's like to work in a real tech job.
So let's zoom out for a second and just look at what you've accomplished. These 3 projects, they aren't just random exercises. Together, they form a powerful toolkit that actually prepares you for real-world development work.
This table pretty much sums it all up. The calculator, that taught you the core logic behind backend services and APIs. The guessing game, that taught you about the interactive loops used in game development and AI simulations. And the file organizer, that gave you a direct line into the world of automation and DevOps. You haven't just learned some Python syntax, you've learned how to actually apply it. So there it is. The path is laid out right in front of you, from foundational logic to interactive design, all the way to powerful automation. You now have a clear step-by-step roadmap to go from being a learner to being a builder. So the only real question left is,